As you probably already know, Next.js comes with the ability to add what they call route handlers, which essentially allows you to build an API in your Next.js application, making it really a full stack solution. But we can even do better than that. We can add something type safety, right? Add both compile time, development time, and even runtime that'll allow us to make an even more robust app, break less things, move faster. And today I want to tell you how to incorporate something called tRPC, which allows you to do that in any API really into your Next.js application. And I'm going to go through from the basics of what exactly we're working with, like the concepts within tRPC, and then we'll actually show how to integrate it in with our Next.js app and use it in a real application. I'm going to be using my own application called DevKafe, which you can find a link to in the description below. It is the cookbook app for developers. So if you want to make a recipe, if you want to maybe share how you solved a certain problem, or if you want to document how you solved a certain problem for yourself at a later time, that would be a perfect time to use DevKafe. So link in the description below if you want to check it out. The first thing that I want to go over are some concepts of tRPC because you maybe haven't heard of it before. And so it is a TypeScript implementation of RPC, which stands for Remote Procedure Calls. And this basically allows us to interact with an API as if it's functions in our code. For example, in a typical REST API that you're probably used to already, you have these endpoints, and they would look like this right here. Under REST API, you would use maybe the fetch API, or you might use another package such as Axios or something along those lines. And you would type in the endpoint that you want to hit. You would provide maybe a body and the method if necessary. You would provide the method and then the body for the call if necessary, depending on the method you use. And then you would await the JSON again to go and actually get the data or the body from the response. And this is fine, except that it's a little bit different. You're probably very used to doing it, but all of our code is already, we already call functions in our code. So why not just have this kind of work as functions that we can call in our code? And this allows us to have type safety. So this is where tRPC comes in. Instead of calling an endpoint, you would define what are called procedures. I'm going to talk about that in a second here. You would provide what you call procedures, and you would basically hit them or call them as if you're calling a function, and the tRPC framework will take care of the rest, where it'll actually make the HTTP calls for you in order to hit the API that you define elsewhere, which we'll also talk about in a second. So as I mentioned before, these are called endpoints here, and these methods that look like methods that you're calling, those are procedures. And there are actually 3 types of procedures, but only 2 that we're really going to care about for now. The third one, which are called subscriptions, is something that you might have a need for, but we're not going to cover here. So the 2 that we are going to talk about are called queries and mutations. So let's say that you have a database, which you may very well have, and you want to stand up an API in front of that database. Again, if you're using Next.js, and especially if you're using the route handlers, you've already created that API. And queries, so imagine that this API, instead of being like our route handlers, is actually tRPC. So let's go ahead and put in here, say tRPC, right? And so we create our tRPC API, I said that right. That lives in front of our database just like a normal API would. And then we're going to have queries that get data, so we're querying data, and mutations that are writing data, and just like how you would have like a post, a patch, or a put kind of a thing. And so those are really the main concepts and vocabulary that you need to know about. So why would we want to do something like this? Like we already have the fetch API, we already have the route handlers, we have the fetch API, we probably know how to use both of them, right? Why should we care about this? Well, really, Node.js, while it allows you to create these APIs, you don't get any type safety that comes along with them. So in this example, if we are making a call to a REST API, this is the same code that we had up here, by the way. So I just copied and pasted it. So we have no type safety that comes along with this, right? So during development time, if we're passing in an object as the body here that this endpoint cannot accept, it doesn't know anything to do with it, when we go to call it, we're just going to get an error. It's actually not going to be able to tell us ahead of time during development that there's a problem. Additionally, during compile time, it's also not going to help us at all because it has no idea. And as a last thing, it also, like I mentioned, during runtime won't help us either, because it'll just error out if we go and make that call. Whereas here with tRPC, by using this framework, we can actually get type safety during development. So it'll tell us what we need to actually give the API. So that's awesome. We can get it during compile time. It'll error out if we try and compile something that is not type safe. And then also during runtime, it will actually throw back an error and it will say, hey, you didn't provide this data structure, and it'll give you the data structure that you need to provide, or it'll tell you that what you provided does not match up with whatever it needs. This is something I've actually used this not with TypeScript, but in the past. At a previous job that I had, we used something called tWRP and protocol buffers, and then we would generate from our protocol buffers into basically a tWRP API. And then we also had a generator which would generate from the protocol buffers into our ORM that we were using, which was called Ent. So we were using Go. And so we could have everything working together just based off of our protocol buffers, which were what really defined what our data looked like. More on that in a second, because it's an interesting thing that I want to talk about here as well, but we will get into that. So this is generally why we'd want to do this. The fact that we can have a framework totally take away all of the work or much of the manual work for us is incredible. We could, of course, do this. The development and compile time type safety, we, not to the best of my knowledge, cannot get from using a traditional REST API. But we could get that type safety at runtime from a REST API if we were using something like Zod, but we'd have to do a bit of manual work for us, or ourselves. In this case, we're going to have to do less manual work, and then something that I'm going to show you later on with a problem that I realized and have a solution for is actually going to result in even less manual work, which is really great, and I think it'll help make your code a lot safer. Let's go ahead and talk about how this fits into a Next application. So I have some stuff up here that I'm covering, but basically this is what you're probably used to seeing. So inside of our Next application, we have our app. You might also have a source directory, but we have an app directory, and using the app router, this is where all of our, front end code lives, if you will. So we have actually back end code too, if you're using server actions, but this is where all of our application code lives, right? And so you would have these folders and directories and such that basically create the routes that will exist inside of your Next application and the pages and so on and so forth. And then you might have another API directory, and this is where your route handlers will exist. You probably already know that. Now what we're going to do is we're going to have a new directory that is for tRPC. And this is essentially going to be like its own API. So everything in here in blue is what the tRPC framework will have ownership over. And we create our procedures within here, and they will basically be what we call. You could actually, I believe you can also call them directly as RESTful endpoints. But we will interact with them from within our application as just functions that we call. But let's say you wanted to have like a React Native app. You could use this and just call, I'm pretty sure you can just call the actual endpoints as if they were RESTful endpoints. So that's something to keep in mind. Now, then what this allows us to do, we can basically just call these here as if they were functions in our code, like we saw earlier, right? I think I did that right. And so that's basically how our code will work, right? Now, it should be noted that you see that there's still auth here, and I still have webhooks. You might still want to have that. If you're using something like Next.auth, you'll still want to have your own /auth endpoint for that plugin, that package to be able to use. Same thing with webhooks. Let's say that you're going to be integrating in with something like Clerk or Stripe or whatever else. You will still want to have traditional route handlers for those endpoints so that you can, accommodate those services and work with those services accordingly. So tRPC really is going to just be for the things that are inside of your own application to be able to work with them. And that'll be how we really, from our application, work with stuff. I want to also really quick share the problem that I thought of, and then I'll show you guys actually what we're going to be doing to solve that problem. So the problem goes like this, right? Let's say that we have our database. Ooh, my bad. let's say that we have our database, and inside of our database, we have a users table, recipes, steps, comments, settings, and ingredients. This is again for DevKafe. Each of these are a model, collectively all of our models, and they create like a schema, right? And each model adheres to the structure that we prescribe. Okay, so I use Prisma, so I define all of my models using their DSL. You might use something else, and so you'll want to find another package maybe that can do this for your own ORM or whatever way that you interact with the database. But at least for me, this is how this kind of works, and I found it to be pretty useful and a pretty solid solution. So we have each model that adheres to a structure that we prescribe. Each structure is essentially a type, and in fact, in Prisma, it will generate for you actual TypeScript types that you can use in your application, which is super useful. Now, it would be really helpful if the database could dictate the types for the input validation. So within you're going to see this in code shortly, so don't worry if it doesn't really make sense. But in tRPC, we have an input method that we can call that basically allows us to pass in like a Zod schema that we can use to validate the input that we're sending in whenever we call that endpoint or whenever we call that function, right? That procedure. And we can define that ourselves. However, if we define the Zod schema ourselves to use during validation and we make a change in the database, we then always have to remember to go and update the Zod schema. And that's sort of a pain in the butt. What would be much better is if we could just have the database dictate what the Zod schemas should look like, as well as dictate what its own schema and model structures should look like, right? That way, everything is always in sync. This won't always work or be the case that this pans out because maybe your structures that you want inside of the input are a little bit more complex, like maybe they combine multiple Prisma or database models together, as I have. So for example, actually, I'll just show you the example later. But you could probably work around that. Like maybe you could create a TypeScript type or a Zod type that combines multiple of them. So you're still able to get some of that validation, but you still have to kind of combine things. So really just depends on how complex things are. But when you can do this, like for example, something a little bit more basic, like creating a user, you'll probably just be creating a user and using no other types, which is what I do. Then it can be very, very helpful. And so that's kind of the solution, is that we want to actually use a generator, which I found one for Prisma, that takes your Prisma models and creates Zod schemas from them. And that is what we're going to be doing to solve this problem, to allow our database to always dictate what the structure of our API should look like as well when appropriate. We don't always have to use this, but when appropriate, it's super helpful to have it in place. Okay, let's go ahead and take a look at a working example so that we can see actually how this would come into play and how this would be implemented. If you go to tRPC, there are docs, client usage, and then next integration, right? You'll be able to find here setup, and then I'm using the app router. So I'll go to this page, which is set up React Server Components, and that's what we're going to be following. And the first step here is to install all of these packages that they have. You'll want to get that, after which you'll be set to follow the rest of this tutorial. The first thing that we'll do is go into source, app, and then we'll go down, actually it wasn't actually in app, sorry. We'll go into tRPC and we will add that directory inside a source called tRPC, and then add an init.ts file. And you'll want to add this code right here. And essentially what we're doing is actually creating the tRPC context, which is going to have information that all procedures can get access to. So for example, this is where we might store information about authentication or which user is signed in right now, or if maybe the fact that there's no user signed in right now. Then we'll create tRPC. This, we just save that as T. And from there, we want to create and export a few things. So we want to create and export these individual things instead of exporting the entire tRPC object that we have. So we'll create our router, right? And then we will create a caller factory. And then we'll create the base procedure, which also, that was what they called it in some of their code. And then in other code, they had called it like a public procedure. So it just kind of depends. But there's no prescription as to what you call things really. But we'll call that right there, and then we'll export that. Next, we'll go into routers. And so you could create as many routers as you wanted to, but this is where the actual endpoints are going to go, or procedures are going to go. So we create a new router. This comes from this tRPC router that we had here. We create a new router, and this is where we can add all of our procedures for this specific router. You might have other routers as well, but this is where we can create our procedures that we want. And of course, you can kind of, you can refactor this code, because this does get a little bit lengthy, especially if you have a bunch of these procedures, that you can, of course, extract this code elsewhere and kind of treat them as like handlers, maybe if you were building an Express app or something like that. So we have that here. I'll show you how this is going to work as well when we finish setting this up. Now what we'll do is inside of app, we'll come into here inside of our API directory, and we'll go and create a new tRPC directory, and then we will put in brackets tRPC, and then we'll put route. And this is basically what's going to create all of the routes that we have based on the procedures that we have. So these will all become routes, right? So we export all of them, or we export our handler. And this basically is why our tRPC router is kind of, it's technically just a route within Next.js, but it gets treated basically as its own API all underneath that tRPC route that we have. And as you can see, I said that my endpoint is going to be tRPC, and then I think it's either slash the procedure, or I think it might also be or it could be a dot the procedure. I think it's dot actually. But basically this, if you wanted to hit these things yourself, you could still do so from right here. Let's now create our query client, which will go back to our tRPC directory, which is outside of our app directory. And we will go ahead and make our query client, which is going to allow us to make queries just as you might expect. So what we're doing here is we're setting the stale time basically so that with SSR, we don't want our client to requery the data immediately. So this basically makes sure that it doesn't do that. Essentially what we're doing is we're saying, so since React Server Components can hydrate pending queries, like pending promises over the network. I think I actually made a video about this that kind of shows that happening. Basically, we want to allow those queries to finish and not be redone immediately. We want them to be able to finish once they're on the client. And so that's why we're doing this here, to make sure that anything that's in a pending state has the time to finish. So we're giving it 30 seconds. Otherwise, it would just basically be refetching stuff all over again, and that isn't really what we want. Next thing that we're going to do is, if you want to make queries inside of client components, we're going to create a client.tsx file here, and we're going to pass this in so that we can make our queries from we can make queries. We can call procedures from client components just as we can from server components, which we're going to be doing next. So that's basically all this is doing. I think this is probably one of those more of set it and forget it things. But also keep in mind that this is set up for Vercel, so you might have to adjust this accordingly if you're not using Vercel. But that's essentially what this is doing. And then we're going to, I believe, wrap our application with this, and then it should basically allow us to make those queries or call those procedures from the client. But next, as previously mentioned, we're going to do the same thing, but for the server. And so note that this is server only. So we're using server only, which means that this can never be executed on the client. And so that's basically what we're going to do is we're going to have this hydrate client here and tRPC that we will both use for anything that happens on the server. The next step is to go and wrap our application or our page or whatever we need in tRPC, this hydrate client thing here. So we're going to go and do that. Where did I do this? So I put the tRPC provider, which goes to the client. I wrap the entire thing in that. So inside of your layout, go and wrap. I have providers that have all my providers, but go and wrap your tRPC provider. So wrap everything inside of that, which will allow you to use tRPC across your client in any way that you would use any other provider. Okay, so now let's try using our API here. So what we're gonna do is inside of my recipes, and by the way, I'm already doing that here. I have this right here, right? Inside of my recipes, I used to be using the fetch API, and instead what I'm gonna be doing is I'm gonna just have my recipe or user recipes, recipe with everything. And this is going to get an array of recipes with everything. And everything includes the steps that are in the recipe as well as the user information or the author information. So what we'll do is we'll go back and we'll call this procedure right here, get user recipes, right? That's my Prisma query here. And it will go and get them. And then if we log them here, we'll run this npm run dev. You'll be able to see that we'll get our recipes just the same as we would any other way. So let's go ahead and do this. And we have our recipes right here, right? Just like we wanted them to be, right? So we have this here. So we have the author, we have my information here. And then we have ingredients, Next.js and remix. And then we have the steps. So if we were to go in, I'm assuming that this is the first one. If we were to go into here, we would have all of this stuff basically. Let's see, 0, lorem. Yeah, that looks about right, I think. That's how we're able to use tRPC, right? Now, let's say that, as I mentioned, we want to have some validation here. So right here, we only need a string, right? And that makes sense. All we're passing in is a string here. But let's say that we wanted to have that validation I was talking about. So what if we wanted to create a new user, right? But what we really want, so create user, and let's say this is going to be a mutation. And I'm actually not going to go and create a user here. What I'm going to do is just, I would just return. Oh, sorry. We'll log out the new user here. Whoops. Can't see. I use my peripherals to type, and I have the mic in front of the keyboard, so that's why I'm always bad at typing. Let's do options, input, and so what we'll do then, and we'll also just return that right away. Now here, what we could do is we could go and create our own Zod object, right? We could do that. However, I have users here. I already defined what a user should look like. And I would really like to use this definition of a user when creating that procedure. And I don't want to have to manage this definition here and then a Zod object as well. It doesn't really seem like a very efficient way to go about doing things, and more importantly, it seems like a really easy way to break stuff when I inevitably make a change in the database and forget to do the same thing in Zod, or maybe do it manually. Of course it's manual, and maybe I make a very slight mistake that results in something breaking. I would like to have Prisma and Zod do everything for me. This is the package that I found that allows you to do this. It's called Zod Prisma Types. It seems to, be actively developed 8 days ago. And it seems to have quite a few people using it. It's got a nice MIT license, and it seems to be pretty feature rich from what I can tell. So let's go ahead and install this. I actually already have it installed, but just to show you how to use it. And then let's go ahead and actually do something with it. So we will add a new generator to our Prisma schema here, which will go in here, and I already have it, right? So I'll just do that. I can hit generate, that's nice. VS Code gives me the button. But what we're actually gonna do is, and actually this stuff might be here already inside of generated.zod or /zod, but I'll go and delete this just to show you. We're gonna go and run this npx prisma generate zod here. And what we're going to get is a new generated folder that has all of these types created for us all of these Zod schemas that are created for us based on our Prisma schema. So now what we can do is we can come over here in app, and instead of creating our own Zod schema right here, we are going to do, let's say, user, I don't know actually which one we want though. I think it's just user schema maybe. Here, user schema, let's see that. This looks like what we want here, right? So I will save that. And now let's just add maybe like a, well, I can just show you here. So let's do on this page, we can just do this right here. And so we'll say new user. Let me also make sure that DevKafe is running locally. And this is going to return a user from the Prisma client, I believe. And what we can do is we can do tRPC create user. This should basically give us what we need here. And so now we could create all of these things here, and it would essentially help us with our validation here. But, right, so like if I had something different like DOB for day of birth, that wouldn't work because this doesn't take in a date of birth field. Now what we're able to do after we've generated all of those Zod types is we can go ahead and use that as our input validator here. So from our Prisma model, we were able to create Zod schemas, which now we can use inside of our input types for input validation for tRPC, which means that we'll be able to have runtime validation based on the actual objects that we have in our database, and they will always be in sync. So then on our front end, what we would do is we would actually go ahead and call our create user, pass in whatever we need. I needed to cast it here with this as user thing here to get this to work. I don't know if maybe there's a better way of doing this. I have to maybe give that a little bit more in-depth look there and maybe report back, maybe make another video or something like that. But this did ultimately work for me. And now if I go and request this, I will be creating a new user with the data that I wanted to send in. And I've got all of the validation and type safety that I would need when developing this application, which would actually result in much better and more reliable applications. So hope you guys enjoyed. If you want to see a written out version of this tutorial, you can go down in the link to devkafe.com and you can find it there. So I've started posting my own recipes there, so you can go ahead and check that out. And I would also highly encourage you to join DevKafe. It's the cookbook app for developers. And yeah, hope to see you guys over there. And thank you so much for watching.